All right, students. So here, this is the quadratic matching activity that we were working on in class today. And I just wanted to go over how you can quickly identify the different equations that match with each of these graphs. And it's always based on looking at the vertex, x-intercepts, and y-intercept. One thing I will mention, because you got the equations all handed out to you, is you know that all of the a values are equal to 1. And so that's a really nice thing. You don't need to worry about solving for the a value as you go through this. So I'll show you just a couple examples. This one right here, I identify my x-intercepts as -4 and +6. Just notice that each of my boxes counts for 2. The vertex then looks like it would be 1 comma -25. So then looking at the x-intercepts, when x is -4, I know I write a factor of x plus 4. When x is 6, I write down x minus 6 here. When I look at the vertex, I write x minus 1 squared minus 25. And these two equations match up with each other. And I can get the standard form by multiplying these equations out. And I can do either one of them. So let's multiply out the factored form. X times x times -6, 4 times x, 4 times -6. So we get x squared minus 6x plus 4x minus 24. Combine my like terms to get x squared minus 2x minus 24. It should be the same thing if I multiply out my vertex form, x minus 1 times x minus 1, and then I have a minus 25 there. So I do x times x times -1, -1 times x, -1 times -1. That makes x squared minus 1x minus 1x plus 1 and minus 24. I hope you can see how these two -1x's make -2x. And oops, I messed up. Here's a 25, so it should be 25. 1 minus 25 makes -24 right there. And so that's my standard form. I can get there from either my vertex form or from my factored form. It's a little bit more complicated when the a value is not equal to 1, but when the a value is equal to 1, your equations are a little bit easier to convert. So just as a reminder, you should definitely have this written down in your notes. Factored form looks like this: a times x minus p times x minus q. That's how I started with this version of the equation. Vertex form looks like this: a times x minus h squared plus k. That's how I got this version of the equation. And standard form looks like this: ax squared plus bx plus c. A really good double check is that the c value should match up with your y-intercept, and it does. So I'll just knock out 2 more examples and then we'll call it good. If there are any of these that were tricky for you, please just ask. Happy to do them. So let's do this one right here. So this looks to me like -1 and 9 are the x-intercepts. So I can write x plus 1 times x minus 9. I can multiply that out to get x squared minus 9x plus 1x minus 9, which makes x squared minus 8x minus 9. I can find the vertex right in the middle there at 4 comma -25, I believe. And that gives me y equals x minus 4 squared minus 25. As a quick double check, if I do 4 squared, that's 16. And 16 minus 25 gives me -9. So I know that I have the correct 3 equations: factored form, standard form, vertex form. For the last one here, let's just knock out this one right here. Looks like we have an x-intercept of -3 and an x-intercept of +5. Vertex looks like it's at 1 comma -16. So I have x plus 3 times x minus 5. I have x minus 1 squared minus 16. And if I multiply out the vertex form, I get x squared minus 1x plus 1 minus 16, which is x squared minus 2x minus 15. That agrees with 3 times negative 5, giving me negative 15, and it agrees with 3 plus negative 5, giving me negative 2. So please practice it. This is a sort of skill that will help you a lot this year, and it'll also help you out when you take Algebra 3-4 in a couple years. Ask for help if you need anything.